Unit 1.10, Types of Discontinuities. So, types of discontinuities. For the first one, you can see there's a hole right here, where's the open circle. So it's called a hole or a removable discontinuity. Right here, there's an asymptote. So we call this an infinite discontinuity. And right here where the line jumps, very simple, we call it a jump discontinuity. For each function, identify the type of each discontinuity and where it is located. So for here, for number one, we're gonna want to start by factoring out this function. So x minus 6 multiplied by x minus 2 over x plus 5 multiplied by x minus 2. You can see that these cancel out, and anytime what's it called? Anytime something cancels out, we know right away that there's a hole at wherever it cancels out. So x, in this case, is a hole at x equals 2. And the denominator, there's always going to be a vertical asymptote as long as there's a denominator. So we know that it's infinite discontinuity at x equals -5. Number two, same deal. We're gonna want to start by factoring this out. This factors into x minus 1, x plus 1, x squared plus 1. Factor this out. We know that this is a hole at x equals -1, and infinite discontinuity after x equals 1. Number three, we'll start by making this tangent to x equals, we know sine over cosine equals tangent, so we'll make this sine 2x over cosine 2x. Cosine theta equals 0. So when theta equals 0, theta equals pi over 2, 3 pi over 2, or when cosine equals 0, you know theta equals 5 pi over 2 and 7 pi over 2. 2x equals pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. And at x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And we can see that it's an asymptote, and it kind of looks like this. There's an asymptote right here, and the asymptote right there. And anytime there's an asymptote, we know that is infinite discontinuity. On this one, there's nothing we could really do with this, so we say that it's continuous everywhere, and there's no discontinuity because there's nothing to find, there's nothing to do with this equation.